Let's talk about methods of charging a body. Methods of charging a body. Let's talk about methods of charging a body. Okay, the first method is called conduction, right? How you can induce a charge in a body using conduction. Let's say, suppose we have a conductor, metal conductor, okay, all the metals are conductor, good conductor, and I want to charge this particular body, right? So now what I will do in the conduction, I will take another body and which is already charged, let's say it is charged with a positive charge, and now I will connect these two bodies with a conductor, or I can touch these two bodies all together, right? Correct. Now let's clarify this. This is a stand which is an insulator. Why it is an insulator stand? Because if it is a conductor, the excess charge will go to the ground and this will become neutralized. We don't want that. That's why we have put here an insulator. Now this excess positive charge will transfer from this body to this body because of the conduction, and here also the same case, they are touching each other. So now this will be positively charged and this will also be positively charged. So you can see in the conduction what has happened, we ended up charging this neutral body here, right? The neutral bodies have equal number of positive and negative charge, but this has excess, so this charge is transferred here, right? Now this type of charging is only possible in conductors. If you don't have a conductor, it is not possible. In insulators you cannot do that, because insulators cannot allow the flow of charges, right? Actually what has happened here, the electrons are actually traveling from here to here. I am saying that positive charges are traveling from this body to this body, but electrons are actually traveling. But we say, okay, conventionally we can say this positive charges and gone there. Electrons gone from here to here means positive has gone from here to here, right? Okay. And one more thing is to understand why these positive charges have to go at this place. Why these positive charges are supposed to go from this place to this place. The answer to that is to minimize the potential energy, right? Minimize the potential energy, they have to go here. I will teach you in the upcoming classes in more detail about that. So what this you can understand like this, positive are crammed in a small space, you can imagine, and they are repelling each other. Now if I repel this all positive charges are repelling each other. So if I touch this sphere, they will have more space, so they can go and go farther away from each other, so that repulsion can be reduced, okay, and they will go farther and they will go on this particular sphere, and as a result this will get charged. Okay, so this is only happened in conductors, right? Let's look at the next thing, charging by induction. Okay, charging by induction. Unlike the conduction, the induction will not require a contact between the bodies. If I have a rod here which is positively charged, and let's say I have a conductor over here, right? So if I bring this positive charge here near to this conductor, see, this body can be conductor or insulator, it doesn't matter. But while holding this conducting body, you should hold it with an insulator. You should use a insulating gloves or something like that. Otherwise these charges will be conducted by you and it will be neutralized. Okay, so now the positive charges are near here, so electrons will get attracted here and positive charges will come up over here, right? Now you have achieved the separation of charges, you have divided them, right? So you have not actually charged this body because it is still neutral, right? It is still neutral, but you have achieved the separation. Now if you connect this to the ground, what will happen? The electrons from the ground will come up and neutralize this positive charge, and you will eventually end up, okay, so while this rod is near to this sphere, that time only you have to do earthing, otherwise it will not. Otherwise if you remove this, they will again come together and neutralize each other, right? We don't want that. So the rod should be present here, then and then only these electrons will neutralize this part, and this sphere will become negatively charged. That is how you can achieve this induction. In this case, you are inducing opposite charge, right? Induction differs in a conduction in a way that in this case, it induces a opposite charge. If you used a negatively charged rod, you will induce a positive charge. But here the contact is also not there. Here the contact is necessary. So these are the differences. There is another way, another method. Is it visible? Yes, it's visible. Okay, another method is also there, in which what you do, you take a rod which is positively charged, suppose, and you take two bodies, two conductors which are in contact with each other. They are on an insulator stand. This will become negatively charged, this will become positively charged, right? Why these negative charges will be on this surface and positive charge will be on the farthest surface? This is the farthest surface. They will not come up over here because they will be going here more easily, right? Because it is farther than this. Now, when the rod is closer to this sphere, if I separate them, then what I will see, this is becoming negatively charged and this is become positively charged, right? So this is how happens in induction. This is another way. Here you will get two types, positive, negative. And one more thing, I have shown here 4 positive charges, and at the end, due to conduction, it became 2 and 2. Is it always the same case? No. The answer to that is no, because if these two conductors are identical in size and shape, okay, then and then only you will have this situation. Otherwise, this situation will not be there. If this radius is different, then different amount of charge will be transferred. I will tell you how to calculate that charge transfer, right? When we talk about potential, that time we will see. Now this is enough. This is conduction, this is induction. The third way of charging is by friction, right? By rubbing the bodies on each other. So let's look at that. The third thing is charging by friction, right? Using friction, how can you charge the bodies? Let's say you have a rod. Let's call this as glass rod, right? This is a glass rod basically, and there is a silk cloth. Now, if you rub this glass rod on a silk cloth, what will happen is that the electrons from this glass rod will jump on the silk cloth, and you will end up with a positively charged glass rod and a negatively charged silk cloth, right? So what happened basically? The electrons from this glass rod jumped from the silk cloth. Now why did this happen? So this happened because of the friction. The friction, because of the rubbing part, you transferred the energy to the electrons of the glass rod, and they acquired that energy and jumped from this glass rod on the silk cloth, and they made this silk cloth negative while the glass rod positive, right? Now if you use ebonite rod, okay, if you use ebonite rod and a woolen cloth, right, and the woolen cloth, and if you rub these two on each other, then what you will get is that the ebonite rod will get negatively charged while the woolen cloth will become positively charged. In this case, the rod has become negative charge and the cloth has become positive charge. It has been reversed. Now what decides which material will lose the electron or which material will gain the electron? The answer to that is it depends on the ability of the material to bind the electrons to the nucleus, right? If a nucleus is not able to bind the outermost electrons very firmly, then these electrons are easy to lose. So with giving a frictional energy, they will jump from one material to another material easily. In this case, this glass rod, in the case of glass rod, the electrons were not that much tightly bound compared to the silk. So the one which has a tightly bound electrons, the outer shell electrons, will gain the electrons, and one which has not the tightly bound electrons in a valence shell, they will lose the electron, like that. Okay, so this is the charging by friction. So these were the 3 methods of charging the friction. And one more thing, I said charge is always associated with mass. So when these electrons moved from this rod on this silk cloth, then this becomes lighter. This will become light and this will become heavy. Why? Because the electrons are getting transferred, right? electrons are getting transferred, and electrons carry a mass with them, right? The mass of electron is 9.1 into 10 to the power minus 31 kg, right? If 100 electron transfers, then 900 into 10 to the power minus 31 kg mass has been transferred. The one which gains the electrons will become heavier, one which loses the electrons will become lighter, right? But that will not be that much difference, right? Okay, so this was the ways of charging the bodies, right?